welcome back. So what we're looking at today is 4.6, Bernie's bikes. So let's go ahead and jump right in. So for this first part, we are identifying features of functions. So given each representation of a function, determine the domain and range, then indicate whether the function is discrete, continuous, or discontinuous, and increasing, decreasing, or constant. So we're going to look at number 2. So number 2 here, if we look for the domain, we have -10. So domain, remember domain is your x values. -10 to, well, it goes to 0 for this part of the function, but it picks back up here. And then goes to 3, but then picks up here and goes to 10. So this is -10 to +10. Now, our range, remember y values. What's the lowest possible point we're at? That's -4. Highest possible point is up here at 7. So there is our range. Now, for increasing and decreasing, notice this part of our function is decreasing. This part of our function is decreasing. This is the only increasing portion of our function. So it's increasing from, remember, x values, 0 to 3. So it's increasing from 0 to 3. It's decreasing from -10 to -4. So decreasing from -10 to, oops, not -4. That's my bad. -10 to 0. And from 3 to 10. So remember, we're looking at our x values here when we're identifying these. And this is a discontinuous function. Because there's the breaks, that's why it's discontinuous, but we don't have the gaps in our data. So because our domain went from -10 to 10, that's why it's discontinuous. We didn't have those breaks. All right, the next one we're going to look at is number 4. So first we want to take and do our domain. So what's the furthest to the left that we go? We look, it's -11, so domain is -11 to, follow it all the way over. Here's the furthest to the right we go, which is 9. So there's our domain. Our range, the lowest possible point we are ever at is right here, which is -7. To the highest possible point, which is right here, which is at 4. So there's our range. Now it is increasing from here. So starting about here, it looks like we start increasing all the way until we get to here, and then we start decreasing. So if we look, the value here, x, is -7. And we increase all the way up to 3. So from -7 to 3, we are increasing. We are decreasing from the -11 to the -7. Oops. And then again from 3 to 9. So we can always use our domain to help us when we split these apart, because we know overall it should go from -11 to 9. So we have to make sure all those parts are in there. All right, the next part that we are going to look at, square root functions. The speed limit for driving in a school zone is 20 miles per hour. That seems so slow if you're riding in a car, but have you ever wondered how quickly you could come to a complete stop going that speed? Even if you had super quick reflexes, it would take you over 13 feet. The speed of a vehicle S and the stopping distance d are related by the function s of d equals the square root of 30d. So we want to fill in the table of values for s of d, rounding to the nearest whole number, and then graph this. So we're taking each one of these values and multiplying it by 30, and then taking the square root. So 30 times 25 is going to give us 750. When we take the square root of that, it's going to give us 27.38, so on and so forth. So to the nearest whole number is 27. Now, we do the same thing with 50. 50 times 30 is going to give us 1,500. We take the square root. We get 38.7, so we'll round that up to 39. 30 times 100 is going to give us 3,000. We take the square root, we get 54.77, so we'll round it up to 55. For 200 times 30, we're going to get 6,000. We take the square root of it, we get 77.45, so we'll say 77. And then for 300 times 30, we're going to get 9,000. The square root of 9,000 is 94.868, so we'll round that up to 95. So there are our values. All we did was take the square root of 30 times it by each of our values. So square root of 30 times 25, that's how we found these. So now we want to take and graph these. So at 25, we were at 27. So let's see, going by fives, I believe, and 15, 20, 25, 30, 35, 40, 45, 50. Yep. So 10, 15, 20, 25. We're just a little above 25 because we're at 27. Let me make that a bigger mark. So there's our 27. Then for 50, we're at 39. So that's 30, 35, 40. So it'd be the 39 right there. Then for 100, we're at 55. So we've got our 50 here. So then we go up 5 more. There's 55. For our 200, we're up at 77. So 55, 60, 65, 70, 75, a little above. There's 77. And then for 300, 80, 85, 90, 95. So there is our function approximately. So that is what we're looking at there. Now you're going to use what you found there for 8 and then graphing these, okay? All right, the last section is looking at solving literal equations for a given variable. So we have done these in the past. It's very crucial that you know how to do these. So we are going to look at a couple of them. For number 12, we have a equals pi r squared, and we want to solve for r. So the relationship between pi and the r squared is multiplication. To undo multiplication, we divide. So we divide both sides by pi. So we have a divided by pi equals r squared. Now, how do we get rid of a squared? We take the square root. So our answer is the square root of a divided by pi equals r. There's our answer. All right, the next one we're looking at, number 15, v equals e cubed. Solve for e. So if we take the square root to get rid of a square, we'll take the cubed root to get rid of a cube. So the cubed root of v equals e. There's our answer. All right, and the last one, 16, we want to solve for h. So we have b plus 1, or b1, b sub 1 plus b sub 2 divided by 2 times h. So we want to divide by all of this, which is the same thing as multiplying by its reciprocal. So that means we're going to have a times 2 over b sub 1 plus b sub 2 equals H. There's our answer. All right, your keyword for this lesson is description. Description. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.